All right, we are back for more business, and we're going to do an old exam problem now. And this is a biggie. This will be taking us most of the time for the end of today. So, in fact, let's just call this our last activity. I want you to sit back and try to follow the reasoning, because it's like you're jumping into the deep end here and you didn't get any practice in the shallow end. So there's other videos where there's smaller versions of this problem. There's a supplementary document that has nothing but problems like this. Only problems like this. And it is the last problem on your test. Do not start with it. This is not one that's got like linear. You can't just say, if I do this, put this down, put this, do this. No, it's a new problem every time, and it's problem solving, and it's a puzzle. So I would make sure you allocate 40 minutes at the end and see how many points you can get. Would be a decent strategy, not mandatory. If you love this stuff, maybe you want to start with this, but don't get bogged down and spend an hour and a half on it. Okay, now there's certain features in this area that I like to start with because they're unique. And I'm going to start with a big one. If you see anything with peaks near 7.1, it reminds me of the expression, if you hear hoofbeats, think horses, not zebras. There are other peaks at 7.1, but in this area of the universe, it almost always means benzene. And that is a lot of carbons right there. And because you have 3 peaks on benzene and patterns, you can figure out where the hydrogens are and where the groups are. You have 3 hydrogens, therefore you have 3 groups. There's 6 positions on benzene. So that's where I'm starting. And for one of them to be a triplet means it has a neighbor on each side, because you only have one place to put anything on benzene. So I'm going to copy paste my benzene. So the 7.1 meant this. I'm going to move the 7.1 too. And then down here, I know I have to have 3 adjacent H's. Let me prove that to you. The only one of these that can be a triplet is this one. It has 2 neighbors. Now, these 3 positions here will be groups. I don't know if they're carbon groups or not. The nice generic is R1, R2, R3. I'm going to tell you in very few, like less than a minute, we're going to have 6 points done on this question. Case closed. I've already got 2 for that H because it works. Now, the other ones are I or J, and I would give you full credit for just picking one, calling it I, picking one, calling it J. Now you have 6 points. Because everything you said about HIJ fits the data that's on the question. Why are these doublets? They only have one neighbor. There's the neighboring H. It's a doublet. Why is this a doublet? It has only one neighbor. It's called H, letter H here. And this is a triplet, it has 2 neighbors. These are carbons, therefore they're not hydrogens. If they're not hydrogens, they're not neighbors. Okay, great. I'm going to go with things like 6H and 4H next. There's symmetry. Getting back to the zebras and horses. We have horses in North America, right? When I see 6H's, I think 2 methyls that are identical. I don't typically think three CH2s that are identical. Not as common. Let's go with the hoof beats off the horse, not the zebra. So when I see 6 H's identical, I draw 2 methyls right above and below each other. My question now is, they're both identical so far. I'm not giving you any points yet because you got to match every piece here. I got the 6H piece covered. How many neighbors do you have if you are a triplet? What plus 1 gives 3 is the question, right? You have 2 neighbors. So if you're thinking about just saying this, then think again. They both have 2 neighbors, and that's it. What's wrong with this picture? That's a molecule called propane, and you're done with it. This is not a molecule called propane with a formula of C18H26O4. It can't be a CH2 that's common to both. It probably is this based on the fact that I see some 4s up there too. What does he mean by 4s? I see 4s here and here. These are 4 that are the same. Do you agree? You do, don't you? So right now, you want 2 more points, you just do this. Put an A between those green H's. They fit perfectly. They're RCH3, that gives you a peak at 0.8. They're a triplet because they have 2 neighbors. 2 plus 1 is 3, triplet. And there's 6 H's that are chemically the same. Now I just need to figure out, are these guys going to be C, where 4 H's are the same and it's a sextet, or are they going to be D, 4 H's are the same and they're a D of T? What is that? That's a great question, by the way, D of T. Okay, don't panic on me, this D of T. It's actually beneficial more to you than me. I don't want you trying to write D of T when you do the filling out the table. I don't want you ever doing anything of anything. Just count neighbors, add 1. There's your answer. This one's got more information because this machine is a nice expensive one. What does he mean by that? Well, when your neighbors on each side of you are not, I'm trying to get my hands on the screen. When your neighbors on each side of you are in very different chemical environments, that means they're very different magnets than each other. They have different magnet strengths. Okay? So they do talk a little differently to the guy in the middle that thinks they're both neighbors. And when you have D of T, that is beautiful. It says one of the neighbors, there's only one of them, and it causes a doublet. And the other side, there's 2 neighbors, because that's the only thing that causes triplets, right? So that is wonderful news. These are not D, because on one side, there's definitely 3 neighbors, and I don't see the letter Q here anywhere. Yeah. So we'll talk about him next, D. But we're going to make C work for these black ones here. You're not getting a point for C yet, or 2. You get 1 for the label and 1 for drawing the right picture. It's a sextet, which means you've only accounted for 3 neighbors. You got to get up to 5. Why 5? Because a sextet is 5 plus 1 gives sextet. So I need 2 more neighbors for the black one. Each black one gets, and don't you be putting a CH2 between these and giving me the molecule pentane. That ain't going to fly. All right. And I think we have the other 4. That's got to be the one was the D of T. We're going to make it the one that's the D of T. And that was D. Okay. Let's go back to D of T. I only see the T. What is he talking about? These D. Okay. D has two different types of neighbors. You are told that. That's a fact. We only see one of them here because you came up with this. C would cause a triplet on D. The T is covered. On the other side, there's a C with one H. I think I'm seeing how these might finally connect to each other. A C with one H leaves room for more stuff. And that's kind of the only way to get those to be identical to each other. There's your C with one H. What would D say about that? Doublet. What about this side? Triplet. Doublet of triplets. So on the very expensive machine, you'll see two little peaks. One, there's two of them, and they're both identical looking triplets right beside each other. It's fascinating to see. On a cheaper machine, you're going to count the peaks, and it looks like, because there's two neighbors here and one neighbor here, the total's 3. You're going to get 4 peaks, but it doesn't have a nice quartet pattern because your neighbors aren't similar. I'm going to prove to you that this is not a similar neighbor to this very shortly. And I got great news for you. This can't be the H on a benzene, right? Because there's no way to make that into a benzene. And there's only one of them. Only option is letter G. Please verify. The only option for this is G. Because B has 3 H's and C has 4 and D has 4. G has 1. These guys are covered. You can't use these ones anymore. All right, so we're calling this one G. And we got to get it up to 4.4. That's great news too. G. We're over 10 points, guys. 2, 4, 6, 8, 10, 12, 14. You might want to even stop. 14 out of 20, not bad. And I mean, you could leave it like this and get 14 out of 20. I might not give it for G though, because you don't have the right ppm. What in this molecule is going to bump the ppms up to 4.4? And there's some other things I haven't talked about in this molecule.
Oxygen.
Oxygen is a great choice. Now, if you're thinking, oh, wow, 4.4 is perfect for a fluorine, and you look at the chart and it says, yeah, that's it. Guys, you can't put fluorine in this molecule. It doesn't exist in this molecule. So just because it's on the chart and has the number you want, doesn't mean it's the right one. But oxygen was a great choice. And because it would bump it up. Sadly, I don't have the ppm chart here. I do have it. I'm sorry. I'm going to stop the share here and try to get the exam showing. So stop share here. I know my exam's here, but I kind of come back here. I'm not good with the share part. You know that. Share screen. That's got to be, that's the PDF. Okay, that's where I got the question from. And I'm going to steal the table here. Except my gallery of people's in the way. I'm sorry. You can't see anything, maybe. You can see the exam, right? And we need the chart. We need the chart to be smaller. Okay, I think that's everything I need. Snip doodle. Here it is. All right. Oh, yeah, stop share. And share to the starboard. I almost have to talk to myself to get it right, you know, sorry about that. I tried to paste it, didn't work. Don't do this, please. There it is, it worked. So it's not very big, but the 4.4, these are close, but not quite there. I'm thinking there. Oh, that does a heck of a lot of good for us. That's in there. It's got an O, part of an ester. I'm gonna roll with it and see if we can make it work. O, part of an ester. Now you've got your full credit for G, because that I can't refute that this works. And now we got to talk about some other cool information. We totally didn't even read this. Now, infrared spectroscopy is not part of this course except for this one fact. We use it a lot in Orgo lab, and we don't start that till the second half of the semester. But when you have peaks in infrared anywhere near 1700 reciprocal centimeters, it just means one thing: carbonyl. That is useful information. You're not told it's just one carbonyl, you're told it's two. Okay, we got one on the page. Right there. Two coming up later, I think. Now I got to figure out how this attaches to benzene. Is it the carbonyl that's attached is the question? It might be. I believe we're running out of carbons. That's another issue to think about. Where are we at? We got 2, 4, 6, 7, 8 plus 6 is 14. We only got 4 more carbons. And we've got, let's just cross off things we've accounted for. When we get anywhere near the end, it's good to just do some bookkeeping. We've accounted for A. We've done C. We've done D. And these guys here. And I believe we snuck a G in. So let's just look at what's left, shall we? 3.7 quartet 2H. 3.7. I'm thinking about the other oxygen here with the 3.7. Quartet 2H. That looks this area, doesn't it? 3.7. Now, how do I know it's not the alcohol? I know it could be this hydrogen here, the 3.7, but it can't be this in my molecule because I don't have a 1H broad singlet listed anywhere. And trust me, if there's an alcohol in your molecule, I'm going to say there's 1H and it's broad. I would use the word broad up here because I'm trying to help. And, you know, this data is supposed to represent the picture. And in the picture, you can tell when peaks are broad or sharp. So that's, hey, give me all the information is what I'm saying. So not an alcohol, I'm thinking ether. So 3.7 ether with 2 H's attached. So we're jam session here. 3.7 O CH, why CH2? That's the question, because there's 2 H's. Why do you need a CH3 next door? That is a great question. Quartet. Usually caused by 3 H's next door that are a methyl. Once again, horse beets, not zebra beets. Okay? I'm thinking instead of, well, I don't even have to think about zebras versus horses. You can't do a CH2 and a CH. You got an octet violation on this carbon. There's other ways to get 3 neighbors. So you can have 2 H's on one side and 1 on the other, but that you're out of sides. Guys, this thing's falling apart. It's falling apart. This one, we determined it's F. There's only, and yeah, why not? Go right with the, go to the red. Okay. What does this have to be? You've got 2 choices. It can't be a singlet. Look, it's a triplet. Why is it a triplet? It has 2 neighbors. It's this one. And it's at 1. Why is it not at 0.9 like it could? Well, 1 is in the range. It says 0.8 to 1. It fits that. Why is it on the upper end of the range? The oxygen's close by. Call this thing here B. And it's done. E, 2.2 singlet 3H. And I want to remind you, I think we're down to one the carbonyl. How many carbonyls we got?
We
One.
have 3 left.
We have 3 carbons left? Oh,
15 right now.
okay. Let's verify that. 2, 4, 6, 7, 8, 9, 10, plus 16. Correct? That's a carbon here. 2, 6 is 8, plus 6, 14, 15, 16. 2 to go. And I've only got 3 H's to go. I'm thinking methyl. And I'm thinking carbonyl. What do you got? There's only one option available for our 2 carbons that are left. Because I'm putting this on the benzene. I'm putting this on the benzene. And I'm putting this on the benzene. Why? I want the data. That would be carbon E, right? Or hydrogen's E, 2.2 singlet 3H. Does 2.2 fit? It's H on a carbonyl, 2.2. It fits. Is it a singlet? Are there any H's over here? No. What else? 2.2 fits. 3 H's fits. It's 3 H's. This is E. You leave it like this, I'll give you 19 out of 20. The only thing you didn't do was bring it all together. I don't care which order, although of the atoms attached to benzene here, this one compared to this one, compared to this one, which atom is the most electronegative? It's the oxygen. Which of these peaks has the highest shift? HI or J? J. I prefer this to be the F group right here. This group. I called it F because we were working on the F to get to this point. It's not an F group anymore. But I'm really, if you got those 3 groups and you put them on benzene, I'm probably going to say, I'm so happy. You got it all. Big picture. I don't care what order you put them on. But some people love the truth. So here's the truth, and here's the only thing you have to draw. Okay? If you've been drawing, it's great. But all I really need to see, my benzene with those H's. I'm going to go monochrome here. And their labels. And that was I, H, J. And I said J should be near that ether. O, CH2, CH3. And you can do it like this with stick figures, F and B. Those labels are for the H's, right? And you pick one of the other 2 groups. I'll go the carbonyl that's on the far left of the screen. I better go this way with the carbonyl. And then O, and then a C. And we did G, D, C, A. G, D, C, A, C, D. And the 3rd group was just my carbonyl CH3. Yeah. And that was E. So I'm verifying quickly, copy that whole deal here. And whatever's in this yellow squiggle. And I'm gonna verify I have every letter in there. A, B, C, D, E, F. Where are you, G, G, H, I, J, and we're done. So you copy that down. And I hope it doesn't take too long. And it took less time than I thought. Maybe I'll try to hunt down another one of these. How's that sound? I'll try to find one that doesn't have benzene. So we're gonna restart in 6 minutes at 9:26. That should get you enough time to post. I will change the accepting dates. So this will be due at 9:24, and I'm stopping. I just need this.